Welcome to today's statistics tutorial by CAZ Academy. In today's lecture, we are going to go over the definitions and examples of several random sampling methods. Our first experimental sampling procedure is called simple random sampling. This is when each member of a population has an equal chance of being selected. This would be the same as putting all of the data values in a hat and drawing out the desired number for your sample. This is the preferred or most ideal form of experimental sampling because every member of the population has an equal opportunity, equal chance of being selected. Let's look at an example of simple random sampling. Let's say our problem says choose 5 letters from the alphabet using simple random sampling. Our population would be the 26 letters of the alphabet. With a simple random sampling, we know that each of those 26 letters have an equal possibility of being drawn and represented in our sampling, our 5-letter sample drawing. So what I could do is I could take each letter of the alphabet, put them on a piece of paper, then put them in a hat, and then randomly draw the letters out without looking at any of those cards. That would be called a simple random sampling. On my first drawing of the 26 possible choices, I might have drawn the letters A, B, L, O, and D. That would be one possible simple random sample from the 26 letters of the alphabet. Now if I was to put those letters back and then once again draw 5 letters from the 26 possible letters of the alphabet, I might draw another simple random sample with the letters N, I, D, Q, and M. Both of these are examples of simple random samples. And as mentioned before, the simple random sampling is the preferred or most ideal form of sampling when doing an experiment because every person in the population or every data value in a set of data sets has an equal opportunity to be chosen or representative in the sample. However, based on various circumstances, this is not always feasible or manageable due to size and cost. So let's look at some of the other types of sampling procedures. The next type of sampling is called a stratified random sampling. This is when we're going to divide the population into groups called strata, then take a proportionate number from each stratum. So with this, we're going to divide into groups, and then we're going to do a random sample from each group. So for example, let's say our problem says to create a stratified random sampling of 2 people from each gender. So let's say our population is Nancy, Tom, Susie, Mike, George, Paul, John, Mary, and Jane. So from that group of people, we're going to divide them into stratums of males and females. And then from those 2 gender groups, we're going to do a simple random sampling. So from the male group, I'm going to put those 5 names of Tom, Mike, George, Paul, and John, put all those 5 names into a hat. And then I'm going to draw 2 boys' names out of my hat. Then I'm going to take the 4 girls' names, put those in a hat, and I'm going to randomly draw 2 names out of the hat for the girls. That's going to give me a stratified random sample that might look like Mike, John, Nancy, and Mary. A stratified random sampling is really good to use when you want to make sure that all populations are being represented. So for example, in this particular example, we're making sure that the genders are equally represented in our experiment. Other types of stratified random sampling might include race, country of origin, cities, anything where there are distinct groups and you want to make sure that those groups are all equally represented in your experiment. Let's look at the next one. The next one is called a cluster random sampling. This is when you're going to divide the population into group clusters, then select a cluster group to represent the entire population. A good example of cluster random sampling is to look at the sections of a math course. So let's say that our question says to choose a cluster random sampling to represent all the students taking statistics. So our population that we're drawing from is going to be all students taking the statistics course. Then we could divide them into cluster groups based on their class sections. So let's say that the statistics course has 6 sections where all of the students are divided into. Since we know that the students are randomly assigned into each of the math classes, then we can confidently say that we should be able to choose any one of those math sections, and that would be the students that are taking the statistics course in that particular section should be a good representation of all of the students that are taking statistics course. So then when we're doing our final sample, all we're having to do is look at the students in one section rather than looking at all of the students that are taking statistics. The next type of experimental random sampling is called systematic random sampling. This is when you're going to choose a starting point, then take every nth piece of data. So let's look at some examples. Let's say your problem says to create a systematic random sampling of the alphabet. So that means our population will be the 26 letters of the alphabet. Then we're going to create a systematic random sample where we're going to count every 5th letter to be part of our sample. So as you can see, I've got my 26 letters of the alphabet, and every 5th letter I have highlighted in yellow, and those are the letters that are going to make up my sample. So my systematic random sample would be EJOTY if I chose every 5th letter. Other examples of using systematic random sampling would be taking the voter polls, counting maybe every 10th person that comes out of the voting booth and asking them who they voted for to help predict who's going to be the likely winner. You can also do this with a store, counting every, say, 7th person that leaves a store and giving them a survey or a poll to see what they think about something about the store. These are all considered systematic random samplings. This is a very convenient type of sampling system, especially if you have you're sampling a population and that population is going to be maybe coming and going, or you don't necessarily know how big your total population is going to be. The last type of experimental sampling is a non-random sample, and this is called a convenient sampling or a voluntary response sampling. And this is when you just use the results that are readily available. So for example, this might be going into a store on a particular day and surveying anybody that will talk to you on a particular day. So this is going to give you some feedback, but it's not going to be entirely representative of all of the customers that shop at that store. And so you just have to recognize that this is going to give you some information, but it may not be the full picture or a completely accurate picture about the thoughts and opinions about the customers that you're serving. The convenient sampling or voluntary response sample is probably the most often used because it's the most convenient and it's usually the least costly to do. But it's also the least comprehensive or the least accurate of representing the full population that you are sampling or making predictions about. So just to summarize, the different types of random sampling are simple random sampling, stratified random sampling, cluster random sampling, systematic random sampling, and then our non-random sample, which is called convenient sampling or voluntary response sample. And that concludes our lecture on random sampling definitions and examples. See the links below for additional resources to help you with your academic success, and be sure and like and subscribe to get the latest videos by CAZ Academy. We'll see you at the next video.